Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 21 Trigonometrical Identities. We have studied trigonometry in our previous 9th standard classes. So, we'll be studying these concepts with examples and solve questions from exercise 21A. Hope you all are ready with your pen and papers to solve together. Yes, let's start. Before going into the chapter, why do we need to study trigonometry? Now, what is trigonometry? Trigonometry. Okay. Tri means 3. Okay. Gono means angles. And metry is the measurement. Okay. So, trigonometry is nothing but 3 angle measurement. Where do we actually have 3 angles? When we think about 3 angles, we have our triangles. Okay. So, we'll be discussing trigonometry mainly based on triangles. Not just the triangles, our right triangle. Right triangle is given preference. That is, one angle should be equal to 90 degree and side opposite to this 90 degree will be the hypotenuse. So, trigonometry is nothing but it is a 3 angle measurement. Okay. Now, why do we need trigonometry? For example, in this picture you can see a big tower. Okay. We need to measure the height of this tower. Is it easy to measure the height of the tower? No, right? But after studying trigonometry, trigonometry will be helping us to find the height of tower. Or if you have a tall tree, you want to find the height of the tall tree. Okay, here you will be having a tall tree. Okay, you are standing somewhere here at its base and you want to find how tall this tree is. In that case, trigonometry is going to help us. Okay. Let's see how. What are trigonometrical ratios? Trigonometrical ratios. We need to understand the relation between the sides and angles of a triangle. And these relations we call the trigonometrical ratio. Here consider a right triangle. We have a right triangle which is right angle here. Okay. I am calling this triangle ABC. This is my triangle ABC. What is AB? AB is the base. Okay. BC. BC, we can call this as the altitude or height or perpendicular. Okay. Then we have AC. AC is the side opposite to 90 degree and this is the longest side of the right triangle. AC is the hypotenuse. Okay. We'll be discussing 6 trigonometrical ratios. We have already discussed in the 9th standard classes. So, we'll start with the first trigonometric ratio which is sine. Okay. Now, consider an angle. Here we have angle A. With respect to A, we are going to study all the trigonometrical ratios. First, to find sine A. To get sine A, we need the opposite side and the hypotenuse. Sine A is the ratio of opposite side and the hypotenuse. Here, what is the opposite side? Opposite to A, we have BC. Okay, BC is the height, altitude or the perpendicular. So, perpendicular divided by. What about hypotenuse? We have the hypotenuse, perpendicular by hypotenuse. Here, perpendicular is BC, BC by hypotenuse is AC. BC by AC. So, we got sine. What is sine? Sine is opposite side by the hypotenuse. Okay. Now, the second is cos. Cos of A. Cos or it is actually known as cosine. Sine of A, cosine of A. Cosine of A is adjacent side. Adjacent side by hypotenuse. Okay. Here, adjacent side is the side that touches the angle. Okay, here we have the angle. One part of the angle touches the hypotenuse and the other part touches the base. So, base is the adjacent side of angle A. Here, base divided by hypotenuse. Okay. What is base? Base is AB. AB divided by hypotenuse AC. Next is tan. Tan or tangent. In short, we call it tan. Tan of angle A. Tan of angle A will be opposite side by adjacent side. Opposite by adjacent. First, sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tan is opposite by adjacent side. Okay, what is the opposite side in this case? Opposite side is the perpendicular. Divided by adjacent side is base. Perpendicular. Here perpendicular is BC and base is AB. Okay, so we got three trigonometrical ratios: sine, cos and tan. Next is cosec. Cosec or cosecant. In short, we call it cosec. Cosec of A. To get cosec of A, we need the ratio of hypotenuse and the opposite side. Okay, hypotenuse and opposite side. Here, what is the hypotenuse? Hypotenuse by opposite side. Opposite to angle A, we have the perpendicular. Perpendicular. Okay. Hypotenuse is AC by perpendicular BC. Next one is secant, or in short we call it sec. Sec of angle A. Sec of angle A is hypotenuse divided by adjacent side. Hypotenuse by adjacent side. In this case, hypotenuse divided by the base. Hypotenuse is AC and base. Base is AB. Okay. Now next one, last one, which is cotangent or cot. In short, we call it cot. Cot of A. Cot of A will be equal to adjacent by opposite. Okay. Here, adjacent. Adjacent is the base and opposite is the perpendicular. That is AB divided by BC. AB by BC. Clear? So, we got all the 6 trigonometrical ratios. Next, there are relations between these trigonometrical ratios. We have studied 6 trigonometrical ratios: sine, cos, tan, cosec, sec and cot. How they are related. So, the first type of relation is reciprocal relation. When you take sine, we have sine of angle A is equal to perpendicular divided by hypotenuse. What about cosec of A? Cosec of A is equal to hypotenuse divided by perpendicular. Okay, is there any relation between sine A and cosec A? Just when you take the reciprocal of sine A, we are getting cosec A. So, what is the relation between sine and cosec? They are showing reciprocal relation. We can say that sine A is related to is reciprocal of cosec A. Even vice versa is true. Okay. So, here we will be having sine A is equal to 1 by cosec A and cosec A is equal to 1 by sine A. Okay. Now, if you take cos, cos of A is equal to, what is cos of A? We got base by hypotenuse. What about sec? Sec A is equal to hypotenuse by base. How are they related? They are again showing reciprocal relation. Okay, cos A. When you take the reciprocal of cos A, we get hypotenuse by base, and that is equal to sec A. Cos A is 1 by sec A, and sec A is equal to 1 by cos A. This is how cos and sec are related. Now what about tan? Tan A was equal to perpendicular by base, and cot A is equal to base by perpendicular. How are they related? They are also showing the reciprocal relation. Yes. Therefore, we can write tan A is equal to 1 by cot A, and cot A is equal to 1 by tan A. So, this is the reciprocal relation. Okay. Sine and cosec are related. Cos and sec are related. Tan and cot are related. Next is a quotient relation. Okay. We have sine of A is equal to perpendicular by hypotenuse. What about cos? Cos of A is equal to base divided by hypotenuse. Quotient. Quotient means we are going to take the ratio of this. What is sin A by cos A? Sin A by cos A will be equal to perpendicular by hypotenuse divided by base by hypotenuse. Okay, this hypotenuse and this hypotenuse can be removed. Then we have perpendicular by base. What is perpendicular by base? We have tan A is equal to perpendicular by base, which means sin A by cos A is equal to tan A. This is one quotient relation. Okay, tan A is equal to sin A by cos A. Now the second. Here again we have sin A is equal to perpendicular by hypotenuse, cos A is equal to base by hypotenuse. If I am taking the ratio cos A by sin A, then that is equal to base by hypotenuse by perpendicular by hypotenuse. Hypotenuse and hypotenuse can be cancelled. We have base by perpendicular. What is base by perpendicular? Base by perpendicular we have cot A. Therefore, cot A is equal to cos A divided by sin A. Okay. So, these are the relations. Here we have two quotient relations. When you take the ratio of sine and cos, we get tan, and the ratio of cos by sine, we get cot. Okay, so you understood the reciprocal relations and quotient relations. Next, the third type of relation is square relation. So let us see, consider our right triangle ABC. Okay, for this right triangle ABC, we are considering angle A. We have sin A. What is sin A? Sin A is equal to opposite side, that is a perpendicular, by hypotenuse, which is BC by AC. What is cos A? Cos A is equal to adjacent by hypotenuse, that is AB by AC. Okay. Now, for the first square relation, we are taking the square of sin A and the square of cos A, adding them. What do we get? Sin square A plus cos square A. What is sin A? Sin A is BC by AC whole square, and cos A. Cos A is equal to AB by AC. AB divided by AC whole square. Okay. Here denominator is AC square, and here also the denominator is AC square. We can take AC square common as the LCM. Numerator will be having BC square plus AB square. What is BC square plus AB square? BC. BC is the height and AB is the base. So using the Pythagoras theorem. You remember the Pythagoras theorem? What is Pythagoras theorem? We have base square plus altitude square or height square is equal to hypotenuse square. That is AB square plus BC square will be equal to AC square. So here we are going to apply this. AB square plus BC square is equal to AC square. Then AC square divided by AC square, which is equal to 1. So this is our first square relation. Sin square A plus cos square A is equal to 1. Okay, this is not just a square relation, this is a trigonometric identity, and the first trigonometric identity is sin square A plus cos square A is equal to 1. If you have this identity, you will get two other relations. What is sin square A from this? We can have sin square A is equal to 1 minus cos square A, and if you need cos square A, we will be having cos square A equal to 1 minus sin square A. Clear? So we got the first one. Now to get the second one, we are taking tan. What is tan A? Tan A. Tan A will be equal to opposite by adjacent. Here opposite is BC. BC by adjacent is the base, which is AB. BC by AB. Okay. So 1 plus tan square A. This is what we need for the second identity or the second square relation. 1 plus tan square A. Let's see to which other trigonometric ratio is tan related according to the square relation. 1 plus tan square A. 1 plus tan square A will be 1 plus tan A is equal to BC by AB. BC by AB whole square. Okay. That is 1 plus BC square by AB square. Now denominator will be having AB square. Cross multiplying, we get AB square plus BC square. What is AB square plus BC square? Again Pythagoras theorem. Base and altitude square when taken and added, we will be getting AC square, which is hypotenuse square. We get AC square divided by AB square. Okay. What is AC square divided by AB square? With respect to angle A we are taking. Okay. AC is hypotenuse. Hypotenuse divided by AB. AB is the base. Base. With respect to AB is the adjacent side. Hypotenuse by the adjacent side. Okay. When do we get this trigonometric ratio? Hypotenuse by adjacent side. Adjacent by hypotenuse is cos and hypotenuse by adjacent is sec. Okay. So this is sec A. This ratio will be equal to sec A. Here we have AC divided by AB whole square. AC by AB whole square will be equal to sec square A. Okay. So this is the second identity or the second square relation. 1 plus tan square A is equal to sec square A. From this you can get two other relations, that is tan square A minus sec square A is equal to 1, or tan square A is equal to sec square A minus 1. So these are the relation that we get from the second identity. Okay. Now the third one. Here, what is cot A? Cot A will be equal to, cot is just the reciprocal of tan, AB by BC. We have one more trigonometric ratio that is remaining, which is cosec. Cosec A. Cosec A. Cosec A will be equal to hypotenuse divided by the opposite side. Here AC by opposite side BC. AC by BC. Okay. We need 1 plus cot square A. That is 1 plus cot A is equal to AB by BC. AB by BC whole square. Okay. That is 1 plus AB square divided by BC square equal to, BC square is taken in the denominator. Multiplying we get BC square plus AB square. BC square plus AB square will be equal to AC square. AC square by BC square. Okay, what is AC? AC is the hypotenuse. Hypotenuse square divided by BC. BC is the opposite side. Opposite square. Here we have AC by BC. AC by BC is cosec A. So we get cosec square A. So what is our third relation? 1 plus cot square A is equal to cosec square A. So this is our third identity or the third square relation. From this relation, we will be getting two other relations. First one is cot square A equal to cosec square A minus 1, or the second relation is cosec square A minus cot square A equal to 1. Okay. If you study these three identities, this will be very helpful in solving many problems. Okay. These are the main relations that we need. Okay. Fine. Let us take some examples. Here we have the first example. Prove that tan A plus cot A is equal to sec A into cosec A. We know tan A is sin A by cos A. So we are taking the left hand side. Left hand side we have tan A plus cot A. Tan A can be written as sin A by cos A. What about cot A? What is cot A? Cot A is the reciprocal of tan A, which means when you take the reciprocal of sin A by cos A, we get cos A by sin A. Cos A divided by sin A. Now, in the next step, we are going to take the LCM. Here, we have cos A in the denominator and here we have sin A in the denominator. Then what is LCM? We will be getting sin A into cos A as the denominator. Here already we have cos A. Therefore, sin A into sin A, which is sin square A, plus. Here we have sin A. Okay. Denominator is sin A cos A. Sin A is already there. Therefore, this cos A into cos A, which is cos square A. We have studied sin square A plus cos square A is equal to 1. Yes. Therefore, 1 by sin A cos A. What is the reason? We have the identity sin square A plus cos square A is equal to 1. Okay. Now, what is there in the RHS? Check the RHS. We should get this form. Sec A into cosec A. What have we got? We have 1 by sin A into 1 by cos A. 1 by sin A cos A is equal to 1 by sin A into 1 by cos A. What is 1 by sin A? 1 by sin A is equal to cosec A. What about 1 by cos A? 1 by cos A is sec A. Okay. This is what RHS is. Therefore, we have sec A into cosec A, which is the required RHS. Okay. We are starting from the left hand side and we reach the right hand side. This is how all the proofs are done. In some questions, we'll just take the left hand side, reach at some point, take the right hand side, reach at some point, and they both will be equal. Then we can write left hand side is equal to right hand side. Here we have started from the left hand side and we reach the right hand side. Clear? Next example, prove that cos raised to 4a minus sin raised to 4a is equal to 2 cos square a minus 1. Here again we'll start from the left hand side. What do we have in the left hand side? LHS is equal to cos raised to 4a minus sin raised to 4a. Okay. This cos raised to 4a, I can write this as cos square a whole square minus sin raised to 4a can be written as sin square a whole square. Now this is of the form a square minus b square. In position of a we have cos square a and position of b we have sin square a. We have studied a square minus b square is equal to a plus b into a minus b. Okay. Here a is equal to cos square a and b is taken as sin square a. Then what is a plus b into a minus b? This can be written in a plus b into a minus b form. That is equal to cos square A plus sin square A into cos square A minus sin square A. Okay. What is sin square A plus cos square A? We have the identity sin square A plus cos square A is equal to 1. Therefore, this part becomes 1. We get cos square A minus sin square A. Okay, cos square A minus sin square A. Now what can be done? We have to get 2 cos square A minus 1, which means we need one more cos square A. How can we make this cos square A? Now take the sin square A. There is a relation between sin square A and cos square A. That is, since sin square A plus cos square A is equal to 1, we'll be having sin square A is equal to 1 minus cos square A. You have to check this. Since we need 2 cos square A, we already have a cos square A. We need one more cos square A. For that reason, we are just changing sin square A into another form, that is sin square A is equal to 1 minus cos square A. We are going to substitute it here. That is equal to cos square A minus, in place of sin square A, we will be putting 1 minus cos square A, which is equal to cos square A minus 1. Removing the brackets and multiplying, minus of minus is plus. Plus cos square A. Then what do we get? Cos square A plus cos square A is 2 cos square A. 2 cos square A minus 1, which is the required right hand side. Okay. So we are getting LHS and RHS equal. So this is a required proof. Hence proved. Okay. Hence proved. So what are the steps that we have done here? First, if in the question you have raised to 4 powers and all, you will have to convert it into square of square. Okay. After that, we are using a square minus b square form, that is a plus b into a minus b. Then we will be using the identity sin square A plus cos square A is equal to 1. The same identity we are using again, that is to get sin square A in the form 1 minus cos square A. After substitution, adding cos square A and cos square A, we get 2 cos square A minus 1, which is the required RHS. Clear? Next, problem number 3. This is a question that came for ICSE board exam 2020. Here, we have to prove that sin A divided by 1 plus cot A minus cos A divided by 1 plus tan A is equal to sin A minus cos A. Now, you have an idea how to solve problems. Yes? Okay. Let us take the left hand side. Here LHS we have sin A divided by 1 plus cot A minus cos A divided by 1 plus tan A. Okay. First step, we are changing this cot A to cos A by sin A and this tan A to sin A by cos A. That is equal to sin A divided by 1 plus cos A by sin A minus cos A divided by 1 plus sin A by cos A. Why? Because we have tan A is equal to sin A by cos A and cot A is equal to cos A divided by sin A. Okay. That is equal to. Here, take this denominator. We are going to take LCM for both these. Numerator we have sin A. Here, when you take the denominator, here it is sin A and here we have 1, which means we'll get sin A as the LCM. 1 into sin A is sin A plus, here already we have sin A. Okay, therefore we get 1. 1 into cos A, that is cos A. Similarly, this part numerator is cos A divided by denominator LCM we get cos A. Cos A into 1 is cos A plus 1 into sin A, sin A. Now, taking the reciprocal and multiplying. Here, sin A plus cos A divided by sin A. When reciprocal is taken, it becomes sin A divided by sin A plus cos A. Okay, that is equal to sin A into sin A divided by sin A plus cos A minus here cos A into cos A divided by sin A plus cos A. Okay. Sin A into sin A divided by sin A plus cos A, that is sin into sin, sin square. Sin square A divided by sin A plus cos A minus cos A into cos A is cos square A. Cos square A divided by sin A plus cos A. Okay. Here denominator is sin A plus cos A. Here also the denominator is sin A plus cos A. Now taking LCM, we get denominator sin A plus cos A. What about the numerator? Here we have sin A plus cos A. The LCM is also sin A plus cos A, which means 1 into sin square A. Sin square A. Similarly here, denominator is sin A plus cos A. Here also we have sin A plus cos A. Therefore, 1 into cos square A, which is cos square A. Sin square A minus cos square A is there in the numerator. Denominator is sin A plus cos A. What do we need? We need RHS, that is sin A minus cos A. What can be done? Here this is of the form A square minus B square. We have A square minus B square. Algebraic identity, that is A plus B into A minus B. Okay, A square minus B square is A plus B into A minus B. Now putting this here, in place of A we have sin A and in place of B it is cos A. Therefore sin square A minus cos square A will be equal to sin A plus cos A into sin A minus cos A. What about denominator? Denominator we have sin A plus cos A. Okay, we can cancel these. Numerator and denominator we have sin A plus cos A, which we cancel. Then the remaining is sin A minus cos A, which is the required right hand side. Okay. Left hand side we have started and we reached the right hand side, which is sin A minus cos A. Clear? Understood this problem? Next, example 4. This is a question that came for ICSE board exam 2018. Prove that root of sec square theta plus cosec square theta is equal to tan theta plus cot theta. In this question, we will be taking left hand side and right hand side separately. So here LHS we have root of sec square theta plus cosec square theta. Okay. What is sec theta? Sec theta is the reciprocal of cos theta. 1 by cos theta is sec theta. What about cosec theta? Cosec theta is equal to 1 by sin theta. That is the reciprocal of sin theta is cosec theta. Substituting here, we get that is equal to root of 1 by. If sec theta is equal to 1 by cos theta, what about sec square theta? Sec square theta will be 1 by cos square theta plus cosec square theta will be 1 by sin square theta. Okay. Next step, taking LCM. Here denominator is cos square theta and here it is sin square theta. Therefore LCM we get sin square theta into cos square theta. What about numerator? Here we have cos square theta. Therefore 1 into sin square theta, which is sin square theta. Cross multiply. 1 into sin square theta, that is sin square theta, plus 1 into cos square theta, which is cos square theta. What is sin square theta plus cos square theta? Identity. We have sin square theta plus cos square theta is equal to 1. So applying this identity, we get root of 1 divided by sin square theta cos square theta. Okay. That is equal to root of 1 divided by sin square theta into 1 divided by cos square theta equal to root of. What is 1 by sin square theta? 1 by sin square theta is cosec square theta into 1 by cos square theta is sec square theta. Sec square theta. Okay. Root of cosec square theta into sec square theta. We can cancel the root and square. Then we'll be getting cosec theta into sec theta. What is there in the RHS? RHS we need tan theta plus cot theta. Okay. So we'll stop here for left hand side. Now we'll start right hand side. Okay. Left hand side we have cosec theta into sec theta. Right hand side is tan theta plus cot theta. Again, we know tan theta is equal to sin theta by cos theta. Tan theta is sin theta by cos theta and cot theta is cos theta by sin theta. So, this is what we are applying here. Tan theta is written as sin theta by cos theta plus cot theta becomes cos theta divided by sin theta, which is equal to, taking LCM, here denominator we have cos theta and sin theta, therefore LCM is sin theta into cos theta. Next, cross multiplying, sin theta into sin theta is sin square theta plus, here we have cos theta into cos theta, which is cos square theta. Cos square theta. What is sin square theta plus cos square theta? Sin square plus theta plus cos square theta is equal to 1. Therefore, we get 1 divided by sin theta cos theta, which is 1 by sin theta into 1 by cos theta. 1 by sin theta is cosec theta into 1 by cos theta is sec theta. Okay. So, we got RHS is equal to cosec theta into sec theta and we have LHS is also equal to cosec theta into sec theta. Therefore, LHS equal to RHS, hence proved. Clear? So, in this example, we have taken left hand side. Next, example 5, tan A plus sec A minus 1 divided by tan A minus sec A plus 1 is equal to 1 plus sin A divided by cos A. We'll start with the left hand side. Here left hand side we have tan A plus sec A minus 1 divided by tan A minus sec A plus 1. Okay. We have sec square A is equal to 1 plus tan square A. We have studied this identity. Sec square A is equal to 1 plus tan square A. Then we can write sec square A minus tan square A is equal to 1. Okay. This is what we are going to substitute in place of 1. Here we have 1. Okay. In place of 1, we will be putting sec square A minus tan square A. That is, LHS will be equal to tan A plus sec A minus sec square A minus tan square A divided by tan A minus sec A plus 1. Okay. Why have we done this? Because here we have tan A plus sec A. Okay. Denominator also we have to check. Denominator is tan A minus sec A plus 1. Somewhat relating to this we have to get in the numerator. Okay. The sec square A minus tan square A can be rewritten. We have A square minus B square equal to A plus B into A minus B. Here in place of A we have sec A. In place of B it is tan A. Okay. So, this form can be changed to A plus B into A minus B. Then we will be getting tan A plus sec A minus sec square A minus tan square A becomes sec A plus tan A into sec A minus tan A divided by, denominator we have tan A minus sec A plus 1. Tan A minus sec A plus 1. Now, taking the common term, that is tan A plus sec A is common here and tan A plus sec A is also present here. That is, we can take tan A plus sec A outside, remaining. When tan A plus sec A is taken from this part, we have 1 minus. Here, tan A plus sec A taken out, we have sec A minus tan A. Okay, that is sec A minus tan A divided by denominator tan A minus CK plus 1. Distributing this by removing bracket, we get tan A plus CK into 1 minus CK, minus of minus is plus, tan A whole divided by tan A minus CK plus 1. Okay, tan A minus CK plus 1 plus 1. So this and this can be cancelled. What we need? We need 1 plus sin A by cos A. Here we got tan A plus CK. Tan A is equal to sin A by cos A plus CK. What is CK? CK is 1 by cos A. From this we can take common. Denominator is common, that is cos A. Therefore LCM when taken, we get cos A in the denominator. What about numerator? Denominator here we have cos A. Then 1 into sin A. Sin A plus. Here we have 1. Cos A is there in the denominator. Therefore 1 into 1 which is 1. So we got 1 plus sin A divided by cos A, which is the required right hand side. We started from the left hand side and reached the right hand side. That is 1 plus sin A by cos A. Understood this? Now we'll be solving more problems from exercise 21A. Here we have the first problem. Question 1 of exercise 21A. Prove that sec A minus 1 divided by sec plus 1 is equal to 1 minus cos A divided by 1 plus cos A. This can easily be solved in just 2 or 3 steps. Let us take the left hand side. Left hand side we have sec A minus 1 divided by sec A plus 1. Okay. We need RHS in terms of cos. What is the relation between sec and cos? We have sec A is equal to 1 by cos A. Sec is the reciprocal of cos. Putting this here, we get 1 by cos A minus 1 divided by 1 by cos A plus 1. Okay. Now, when you take this part and take the LCM, here the denominator is cos A. Here we have only 1, which means the denominator is 1. Then when you take the LCM, for the numerator part, we get cos A. Now cross multiplying, 1 into, here we have a 1. 1 into 1, 1 minus 1 into cos A is cos A. 1 minus cos A. Here again this part, that is the denominator part, LCM when taken, here you will be having a 1, cos A and 1, LCM is cos A. Numerator 1 into 1, 1 plus 1 into cos A is cos A. Okay. Now taking the reciprocal of this denominator part, we get 1 minus cos A divided by cos A into, taking the reciprocal we get cos A divided by 1 plus cos A. Multiplying with the reciprocal, cos A divided by 1 plus cos A. Cos A and cos A can be cancelled. Then we are having 1 minus cos A divided by 1 plus cos A, which is the required RHS. From left hand side, we have reached right hand side. This is the required proof. Hence proved. Okay. Understood this? So this is very simple, right? We have done only 2 or 3 steps. Next, second problem, question 5 of exercise 21A. Prove that sin raised to 4A minus cos raised to 4A is equal to 2 sin square A minus 1. We have solved a similar example. Here, LHS, we have sin raised to 4A minus cos raised to 4A. What should be done? When the power 4 is there, here we have sin raised to 4A and cos raised to 4A. This can be written as sin square A whole square minus cos square A whole square. Okay. Now this is in the form A square minus B square. We have A square minus B square equal to A plus B into A minus B. Okay, in place of A we have sin square A, in place of B we have cos square A. This is equal to sin square A plus cos square A into sin square A minus cos square A. Okay, what is sin square A plus cos square A? Identity. We have sin square A plus cos square A is equal to 1. Therefore, this part becomes 1. This is equal to 1 into sin square A minus cos square A. Now, check the right hand side. Right hand side we have 2 sin square A. Okay, so we have to get this cos in terms of sin. Since we have sin square A plus cos square A is equal to 1. What is cos square A? Cos square A will be 1 minus sin square A. Okay, we have to change this cos in terms of sin. Cos square A will be equal to 1 minus sin square A. We are going to substitute it here. Then we get sin square A minus cos square A is 1 minus sin square A. 1 minus sin square A. That is equal to sin square A minus 1. Minus of minus is plus sin square A. What is sin square A plus sin square A? We get 2 sin square A. 2 sin square A minus 1. And this is the required right hand side. Okay. Therefore, this is it. Hence, proved. Similar question we have done. In that case, we had cos. We had to convert it into cos to get the right hand side. Here we need in terms of sin square A. Clear? So, while solving, you have to make an idea about the right hand side. What we have to prove. Okay. Then, what is there in the right hand side? Accordingly, we have to change the left hand side. Clear? Just we cannot do whatever we want. We have to check what is there in the right hand side. Here, instead of changing the cos square A, if we are changing sin square A, we won't be getting the answer. So, it is important that we change the cos square A. Why are we changing cos square A? Because in the right hand side, we have in terms of sin square A. That is why we are changing cos square A. Okay, you have to have a clear idea what we are doing. Problem number 3, question 11 of exercise 21A. Prove that 1 plus tan square A into cot A divided by cos square A is equal to tan A. Okay, here in the RHS we have just tan A. So, this we have to bring into this terms. Clear? So, what is given? Left hand side is 1 plus tan square A divided by cosec square A. Okay. Into we have a cot A. Now, what is 1 plus tan square A? We have studied an identity. Sec square A is equal to 1 plus tan square A. Now, we are going to apply this. Since sec square A is equal to 1 plus tan square A, we can change this to sec square A. Therefore, LHS becomes sec square A into cot A divided by cosec square A. Now, we will be changing all these to sin and cos term. How is sec A related to sin and cos? Sec square A can be written as 1 by cos square A. Since sec A is the reciprocal of cos A, sec A will be equal to 1 by cos A and sec square A will be 1 by cos square A. 1 by cos square A into cot A will be cos A by sin A divided by cosec square A. Cosec square A will be 1 by sin square A. Okay. Now, this cos A and from this cos square A, we can cancel 1 cos A. Okay. Then you have 1 by sin A cos A divided by, here we have 1 by sin square A. 1 by sin square A. Now, we will do the reciprocal multiplication. That is 1 by sin A cos A into 1 by sin square A, reciprocal is sin square A divided by 1, sin square A divided by 1. Now, cancel the sin A and the square. Then we have sin A by cos A. What is sin A by cos A? Sin A by cos A is equal to tan A. we have reached the right hand side. Okay, so this is the required proof. Hence proved. Okay. Do you feel this complicated? No, right? Just we have changed this 1 plus tan square a using the identity to sec square a, changing every terms in terms of cos and sine. After that, cancelling many, you will be reaching tan e. Understood? Let's move on to the next one. Next, problem 4, question 17 of exercise 21A. Prove that cosec A minus sin A into sec A minus cos A into tan A plus cot A is equal to 1. Okay, here this is the left hand side and right hand side you only have 1. We have to solve this to get 1. Let us start. Left hand side. Cosec A minus sin A into sec A minus cos A into tan A plus cot A. Okay, here this cosec A can be written as 1 by sin A, that is equal to 1 by sin A minus sin A into sec A. What is sec A? Sec A in terms of cos, we get 1 by cos A. 1 by cos A minus cos A into tan A is sin by cos and cot A is cos by sin. Cos A by sin A. Tan A sin A by cos A plus cot A is cos A by sin A. Now consider them separately. When you take this bracket, okay, inside this bracket we have 1 by sin A minus sin A. Here what is LCM? Denominator sin A by 1. So sin A and 1, the LCM will be sin A. Next cross multiplying 1 into 1, 1 minus sin A into sin A is sin square A. Sin square A. Similarly, the next bracket. Here we have denominator cos A as the LCM. Here we have a 1. 1 into 1, 1 minus cos A into cos A is cos square A. Now the next bracket. Here what is the LCM? We have cos A and sin A, which means LCM will be sin A cos A. Numerator cross multiplying sin A into sin A is sin square A plus cos A into cos A is cos square A. Okay, what is 1 minus sin square A? 1 minus sin square A is equal to, we have sin square A plus cos square A equal to 1, which implies cos square A will be equal to 1 minus sin square A. Therefore, we can write in place of 1 minus sin square A cos square A. Similarly, what is 1 minus cos square A? Since sin square A plus cos square A is equal to 1, sin square A will be equal to 1 minus cos square A. Now, rewriting, we get 1 minus sin square A cos square A divided by sin A into 1 minus cos square A is sin square A. Sin square A divided by cos A into sin square A plus cos square A is equal to 1 divided by sin A cos A. Okay, 1 divided by sin A cos A. What and all can be cancelled? I can cancel this sin A and this square, this cos A and this square. Then what we have? We have sin A cos A divided by, here again, sin A cos A. Sin A cos A. What is sin A cos A divided by sin A cos A? We'll be getting, cancelling everything, we get final 1, which is the RHS. So, this is a required proof. Hence proved. Okay. This is also very easy. We are just converting this cosec, sec, tan and cot in terms of sin and cos. In most questions, we will be doing the same. Okay. After that, on rearranging and using the identity, we will be getting the required result. Problem 5, question 21 of exercise 21A. Prove that sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cot square A. Take the left hand side. Here we have sin A plus cosec A whole square plus cos A plus sec A whole square. This is of the form A plus B whole square. Again, this is A plus B whole square. What is A plus B whole square? A plus B whole square is equal to A square plus 2AB plus B square, which we have studied. This is an algebraic identity. Now substituting here, in place of A we have sin A and in place of B here it is cosec A. We get sin square A plus 2 sin A cosec A plus cosec square A plus. Now this part cos A plus sec A whole square. In place of A we have cos A and in place of B we have sec A. This becomes cos square A plus 2 cos A sec A plus sec square A, and that is equal to, here we have sin square A and cos square A, taking them together, sin square A plus cos square A. Then we have 2 sin A cosec A. That is, you can write this as 2 sin A into 1 by sin A. Why? Because we know that cosec is the reciprocal of sin. Therefore, cosec A will be equal to 1 by sin A. Plus, then we have 2 cos A sec A. This is again 2 cos A into 1 by cos A. Then, plus, here we have cosec A and sec square A. Cosec square A plus sec square A. Just check if we have included all the terms. First we have taken sin square and cos square together. Then this part we have changed cosec A into 1 by sin A. And similarly here sec A is changed to 1 by cos. Now cos square A plus sec square A. Okay. What is sin square A plus cos square A? Applying the identity we get 1. Now this sin A and sin A can be cancelled. So here we get 2. Similarly here cos A and cos A can be cancelled. Again we get 2. Then we have cosec square A plus sec square A. Okay. Now count this. 1 plus 2 plus 2. 2 plus 2, 4 plus 1, 5. We got 5 plus cosec square A plus sec square A. What do we need? We need 7 as a coefficient. Then we have tan square A and cot square A. So this cosec square A and sec square A should be converted into the form tan square A and cot square A. We know that cosec square A and cot square A are related. We have cosec square A is equal to 1 plus cot square A. Similarly, we have sec square A is equal to 1 plus tan square A. Now we are applying this. We get 5 plus cosec square A, 1 plus cot square A plus sec square A, 1 plus tan square A. Adding 5 plus 1, 6, 6 plus 1, 7. 7 plus tan square A plus cot square A. So this is the required result. We have reached RHS. So hence proved. Clear with this? Okay. Problem 6, question 34 of exercise 21A. Prove that sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. Left hand side, taking left hand side, we have sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. Here when you take the numerator, sin theta is common in both the terms. So I am taking sin theta outside. Sin theta into 1 minus 2 sin square theta divided by denominator cos theta is common. Cos theta is taken out. Then 2 cos square theta minus 1. Okay. Now here we have 1 minus 2 sin square theta. I am going to change this 1. Okay. We have an identity sin square theta plus cos square theta is equal to 1. So here and here we are going to substitute this. Then we get sin theta into sin square theta plus cos square theta minus 2 sin square theta divided by denominator cos theta into 2 cos square theta minus 1. In place of 1, substituting sin square theta plus cos square theta. Okay. Now, we can count this. Now, here we have sin theta into sin square theta minus 2 sin square theta is minus sin square theta. Here we have a cos square theta. Therefore, cos square theta minus sin square theta divided by denominator. We have cos theta outside. Then 2 cos square theta minus sin square theta. Minus of plus is minus. Again minus cos square theta. 2 cos square theta minus cos square theta. This becomes in the form 2 cos square theta minus sin square theta minus cos square theta. That is equal to sin theta into cos square theta minus sin square theta divided by cos theta into 2 cos square theta minus cos square theta is cos square theta minus sin square theta. So, we have a term common in both numerator and denominator, which is cos square theta minus sin square theta. It can be cancelled. Then we have sin theta by cos theta. What is sin theta by cos theta? Sin theta by cos theta is equal to tan theta, which is the required right hand side. So, this is a proof. Hence proof. Okay, problem number 7, question 39 of exercise 21A. Prove that root of 1 plus sin A divided by 1 minus sin A is equal to sec A plus tan A. Here we are doing a different step to solve this problem. Take the left hand side. Left hand side is equal to root of 1 plus sin A divided by 1 minus sin A. Here what we are going to do is, here in the denominator we have 1 minus sin A. Okay, we need a 1 plus sin A to be multiplied with this, so that we will be getting the form A minus B into A plus B, which will be helping us to solve this. Okay, here this root of 1 plus sin A divided by 1 minus sin A, I am multiplying 1 plus sin A with the numerator and denominator. Okay, as I said, here we have A minus B. When I multiply with A plus B, I will be getting the form A square minus B square. For that purpose, if here it is A minus B, then I will be multiplying A plus B. So, when multiplied with the denominator, you will have to multiply with the numerator as well. Okay. Then what is the numerator? Root of 1 plus sin A into 1 plus sin A. That is 1 plus sin A whole square divided by denominator. We have 1 minus sin A into 1 plus sin A, which is of the form A plus B into A minus B, and we know A plus B into A minus B is equal to A square minus B square. That is root of 1 plus sin A whole square divided by A plus B into A minus B can be rewritten, that is 1 square 1, then sin square A. Okay, 1 minus sin square A. What is 1 minus sin square A? We have sin square A plus cos square A is equal to 1. Applying this identity, we get 1 minus sin square A will be equal to cos square A. Cos square A is equal to 1 minus sin square A. Just shifting the sin square A to the opposite side, we get cos square A is equal to 1 minus sin square A. Okay, now substituting here. Now check the numerator. Numerator we have 1 plus sin A whole square and we have a root. So root and square can be removed. Then the numerator is 1 plus sin A. And the denominator 1 minus sin square A inside the root. That is 1 minus sin square A is cos square A, which is equal to 1 plus sin A divided by root of cos square A is cos A, equal to 1 by cos A plus sin A by cos A. 1 by cos A. 1 by cos A is equal to sec A plus sin A by cos A is equal to tan A. Okay. So, we'll be getting sec A plus tan A, which is the required right hand side. So, this is the proof. Hence proved. Okay. Here we have the last problem for today. Problem 8, question 48 of exercise 21A. Prove that cos theta into cot theta divided by 1 plus sin theta is equal to cosec theta minus 1. Left hand side, we have cos theta, cot theta divided by 1 plus sin theta. Okay. Here again, what we are going to do is, denominator we have 1 plus sin theta. We are going to multiply. Multiply numerator and denominator with 1 minus sin theta. Okay. To get the a square minus b square form, we are multiplying numerator and denominator with 1 minus sin theta. Then this becomes equal to cos theta cot theta divided by 1 plus sin theta into 1 minus sin theta divided by 1 minus sin theta. Okay. Now this cot theta can be changed to cos by sin. That is equal to cos theta into cos theta divided by sin theta. Here we have 1 minus sin theta denominator. 1 plus sin theta into 1 minus sin theta, a plus b into a minus b, which is a square minus b square. Therefore, 1 minus sin square theta. Okay. Now, what is 1 minus sin square theta? We have 1 minus sin square theta equal to cos square theta. So, this denominator part becomes cos square theta equal to cos square theta. Here, cos theta into cos theta is cos square theta divided by sin theta into 1 minus sin theta. Now, the denominator part 1 minus sin square theta cos square theta. Okay. Taking the reciprocal, here in the denominator we will be having a 1. Taking reciprocal and multiplying, we get cos square theta into 1 minus sin theta divided by sin theta into 1 by cos square theta. Okay. Cancelling this cos square theta and cos square theta, then we have 1 minus sin theta divided by sin theta. That is equal to 1 by sin theta minus sin theta by sin theta. What is 1 by sin theta? 1 by sin theta is cosec theta. Cosec theta minus sin theta by sin theta, we get 1. Cosec theta minus 1, which is the right hand side. Okay. The right hand side we have cosec theta minus 1. We have got left hand side, 2 right hand side. Cosec theta minus 1. So, this is the proof. Okay, that's all for today. In today's class, we have discussed trigonometrical ratios and trigonometrical identities with examples and solved many questions from exercise 21A. There are a few more questions that are left, which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.